technically, on the cylinder, it's not a prism. Even though sometimes you will see it referred to as a right circular prism. For our purposes, the prisms are going to be anything that has a polygon for a base, right? We're going to talk about that definition of a prism. A prism has to have two parallel congruent bases. Those are what we call the bases. Those are what we're going to use to find the area of our base, our big B, just like we found it when we were finding the area of a cylinder. The formulas initially are going to look exactly like the surface area of a cylinder, and they're going to look exactly like the volume of the cylinder. But we are going to be modifying the formulas depending on the shape of the base. So all of them start out for lateral area, summary of the base comes to height. And then if your base is a triangle, you add the three sides of the triangle. If your base is a rectangle, you use 2 times the length plus 2 times the width, or just add up all 4 sides of the rectangle, right? So, all the faces are parallelograms. The intersection of 3 edges is a vertex. So basically what we might consider a corner, right? So we're more than 2 faces, and faces are something we would call sides. Typically faces are basically flat sides. Where those meet are the vertex. And the most important thing I want you to remember out of this is prisms are named by the shape of their bases. So I underlined it 3 times. You're going to underline it or circle it or highlight it or something. I'll be looking for that when I give you a grade on your notes. Marshall, go ahead and underline. Prisms are named by the shape of their bases. So, the next 3 figures, they have the bases. Well, the third one is hard to see. But that first one has the two triangular bases shaded in, highlighted in green. So there are 2 triangular faces, 3 rectangular faces, right? That is a triangular prism. The only 2 faces that are parallel and congruent are those triangles. So that makes that a triangular prism. So we're going to go ahead and name that. So the one on the right there, it has a hexagonal end shaded in or highlighted in pink. You should be able to see that this other end is hexagonal as well. Those are the only 2 faces that are parallel. So those are if that is a hexagonal prism. Always named by the shape of the bases. Give a pass, Mariah. Okay. All right, second I'm updating my attendance. Okay, this is a hexagonal prism because the base is a hexagon. The prisms are named by the shape of their bases. That's a hexagonal prism. So you'll see here, I'll give you all a second, hexagonal prism. What do you think this middle one is called? Anybody want to take a guess? Rectangular prism. So here's the funny thing. This is a rectangle and this is a rectangle. They're parallel and congruent, right? Well, the front and back are also rectangles. They're parallel and congruent. The 2 ends are also rectangles. They're parallel and congruent. So a rectangular prism actually has 3 pairs of bases. So when you're using the area of the base or the perimeter of the base, you designate a pair of bases, and then you use those in your formula. So technically, you could have different lateral area on the same rectangular prism depending on which faces you designate as the bases. Surface area volume will still be the same. Oblique prisms. So what is the shape of the base of this first one? Sorry? Pentagon, yeah. So we call that a pentagonal prism, but it's oblique. So it's an oblique. It's not a right one. There's not, the bases, the height is not perpendicular between the bases. This one is an oblique cube. It might be a rectangular prism. It looks like a cube to me. But remember, a cube is a rectangular prism, like a square is a rectangle, right? And this is a hexagonal prism. This is an oblique hexagonal prism. You'll notice this hexagonal prism is actually sitting on its bases, right? So the height of these prisms, the height is the distance between the bases, okay? So the height on those rectangular prisms, let's go ahead and put that in. That's the height of the rectangular prism. On this one, this is the height. On this one, this is the height. Another way to think about it is the height of a prism is how tall it would be if it were standing on one of its bases. So the height of these oblique prisms, they're going to have to give us the dotted line between the bases, right? So the height here that would be the height. And that would be when it's perpendicular to the bottom base. And my board is not cooperating right this second, but here, that's the height. Here, that's the height. Make sure you're labeling it. And we're going to indicate that those are perpendicular now that my board is working. Any questions? Alrighty. We are looking at regular prisms only. That means the shape, the base is going to be a regular polygon. They're all the sides are going to be the same for now. Formula is the same as it was for the cylinder. Surface area equals 2 times the area base of the base plus the lateral area, which is the perimeter of the base, times the height. So when we were using this formula on a cylinder, instead of perimeter, we actually used circumference, right? But now technically we are using the perimeter. So this one, you'll see there are 3 rectangular faces, but none of them are parallel. It can't be a rectangular prism. It can't be a pyramid. That's another thing that kids confuse this one with. Pyramids, all the triangular faces are touching. They are not parallel. They meet at a vertex. This is a triangular prism. You can see that this triangular face, this triangular face, they're parallel and congruent. This is a triangular prism. So, surface area equals 2 times the area of the base. Well, the formula for the area of a triangle is base times height divided by 2, right? So that's 2b plus the perimeter base times the height. Well, the perimeter of a triangle is the sum of its sides. So it's side 1 plus side 2 plus side 3. We can't do 3s, just in case they're not all the same length, times the height. We need to put an asterisk here. You see that we have two h's? We have two heights, but they're not the same number. This is the height of the triangle. Does what say S? I'm sorry, say it again. Yes, side 1 plus side 2 plus side 3, but I forgot my S there. Thank you. Correct that. And finally, you'll see in this particular one, these twos are going to cancel, right? So it's going to be surface area equals base times height plus S1 plus S2 plus S3 times the height. If you were finding the surface area of this without one of the bases, though, you wouldn't be able to cancel that out, right? These only cancel out if we're finding the entire surface area, including both bases. That's what this stands for. The lateral area, which is the area of the non-base sides, plus the area of both bases, two bases. If for some reason we're finding the lateral or the surface area of a triangular prism-shaped box or something, and there's not a top on it, you'd have to do base times height divided by 2. But this is if all the faces are included in the surface area. Any questions? All right, this one is a rectangular prism. So this is one where you might have different lateral areas, but typically, unless they tell us differently, we use the bases that are parallel, that the ones that it's sitting on, right? So this would be a base, this would be a base. Technically, there's 3 pairs of bases here. The 2 sides can be considered the bases. The front and back can be considered the bases. Unless they tell us differently, though, typically we use the base that it's sitting on. And this big B tells you this is the base. So this is a rectangular prism. Next, are you keeping up? So it is 2 times the area of the base. The surface area is 2 times the area of the base, but the formula for the base of a rectangular prism is length times width, right? The rectangle is the formula for the other rectangle is the length times the width. Plus the perimeter of the base times the height of the prism. Perimeter of a rectangular base is 2 times the length plus 2 times the width, or I just add up all 4 sides. Remember. So let's take another look. Note the height of the prism or the hop. Is the distance between the bases. Caught up with me? volume. We love volume. Volume is the less complicated one. You're still modifying it for the area of the base. So this tells you here this is the base, but we have to start recognizing this is the basis. So the volume equals the area of the base, which is base times height, and that's height of the triangle, divided by 2 times the height of the prism. Remember, this means it's the height of the triangle. That's the height of the triangular base, not the height of the whole prism. So the height of the triangle. Doesn't matter if it's oblique or not, except that you have to make sure you understand how to recognize the height here. So in this case, this is a rectangular prism. The volume equals the length times the width of the base times the height of the prism. And let's go ahead and remind ourselves once again that this is a triangular prism, and this is a rectangular prism. With me? I told you. So I get started. What kind of solid is this? What kind of prism is this? Rectangular prism. That's right. Now this is the one, the lateral area may be different depending on which pair of faces are used for the bases. And that's only for rectangular prisms. Even so, the surface area and the volume will be the same no matter which pair you designate as the basis. The surface area and volume are always the same. It doesn't matter which pair you select for the basis, you'll always get the same surface area and the same volume. If you're finding the surface area of the entire figure, all faces, including both bases. Like we have been doing, we're going to, if we have to find a dimension or it's not going to be part of the final answer, we're going to write it in the hundredths place. If it's the final answer, we're going to write it in the tenths place. We're going to start with the lateral area. The lateral area, remember, is the perimeter of the base times the height. The perimeter in this case, so this is the base, and this is the base, right? These are the bases. We're going to use the ones that it's sitting on unless they tell us differently. So the perimeter is 2 times the length plus 2 times the width. What is the length and the width of the base? Yes, 7 and 3. So this 7, they tell you how long this one is. That would be the same length, right? So the length is 7 and the width is 3. What is the height of this? Let's move it. Let's go do the height. What's the height of this prism? So 4. They only give you 3 numbers, right? The height is 4 inches. The height is the distance between the two bases. The height is 4. The perimeter is 2 times 7 plus 2 times 3. The perimeter of the base is 20 inches. And the perimeter is length. The lateral area is going to be 2 times the area of the base, so 2 times the length times the width. So 2 times 7 times 3. That's the length of the base, the width of the base, plus the lateral area. Oh, we don't know the lateral area, did we? go back here and find the lateral area. It's on the perimeter of the base, that's 20. Now times the height is 4. So the lateral area is 80 inches. If you don't have to round on the lateral area, you can just plug it into the formula. I'm going to go ahead and just plug it all back in though. So 20 times 4. Perimeter of the base times the height. And that's the surface area, not the lateral area. Not the I'll let y'all check it with me because I kind of messed that up. So this is lateral area. This is surface area. I got ahead of myself. Alright, so now we're going to do the math. So the surface area, 2 times the area of the base, that's going to be 42 plus 80, so the surface area is 122 square inches. Any questions? And the volume, the area of the base, length times width times the height. 7 times 3, length and width, times the height of 4. I think that's 84 cubic inches. Any questions? All right. Example 2. What kind of prism is this? Triangular prism, that's right. So it does have rectangular faces. Those rectangles are the lateral area though, right? So these triangular faces here are parallel and congruent. The rectangles aren't parallel. So this is a triangular prism. So when we're finding the lateral area, we're going to find the length of the side. The sum of the length of the side times the height. So what is the height of the prism? Yeah, be careful. It's 6 inches. The distance between the bases. So find the edge that connects the bases. However long that is, that's the height. So the lateral area is the perimeter of the base. So the perimeter of the base is going to be 8. Right, so this is 8 and 12. But we don't have the third side. So this is 8 plus 12 plus this hypotenuse. So this is a right triangle. The very first time on your homework is like this. You've got to find the side length of the hypotenuse that you could add in for your perimeter of your base. So it's going to be the perimeter, it's going to be 8 squared plus 12 squared equals 6 squared. So 64 plus 144 equals squared. I think it's 208. Yep. Now, we want the length, so we're going to take the square root of both sides. So the square root of 208 is 14.422. This is not a final dimension anywhere. We're going to round that to the hundredth place. So now the perimeter is 8 plus 12 plus 14.42, or 34.42 inches. The lateral area, what we call the C, the perimeter of the base, 34.42 times, what did we say the height was? 6 inches. Uh, 206.52, the lateral area is one of the things they're asking for, so here we're going to round it to 206.5 inches squared. When we use it to find the surface area, though, we're going to leave it at the hundredths and then round it to n. Okay, so the surface area, two times the area of the base. So base times height divided by 2, so we can just use base times height plus perimeter base times the height. So the surface area equals, remember this is base times height of the triangle. Right triangle, the base and height are the legs, the length of the legs. So 8 times 12 plus the perimeter of the base is going to be 34.42 times the height of 6, that's the lateral area. Yes. And we can just do that all the way across on our calculator, so we'll do it for me, and then we can write in the total there. 302.52, so we're going to round up to 302.5 because that's one of our final answers. And that is also inches squared. If we've got the A in it, it's got to be inches squared. And last but not least, the one that's a little bit simpler, the volume, base times the height, when that's the height of the triangle, divided by 2 times the height of the prism. Base and height are the legs, right? 8 times 12 divided by 2 times the height, which is 6. 96 divided by 2. 6 divided by 1. Say it again. 288. What y'all got? 288, and that is cubic inches. The volume is 3 dimensions, right? Area is 2 dimensions with the exponent of 2. Any questions? All right, the next one looks harder, but the next one's actually easier. Y'all caught up with me? Anybody need me to hang out here for a sec? This says find the lateral area, surface area, and volume of the prism. So, it tells you that big B is 80.6. It tells you the area of this base. What shape is this prism? What shape is this prism? Hexagonal prism. Yep, that's right. The bases are hexagons. So it's a hexagonal prism. And we would have to find the area of that hexagon, except they give it to us. So it takes a lot of the work from us. Now, it gives you these dimensions, 5.6 and 4.2. 4.2 is the distance between the bases. So let's go ahead and make sure we know what all the dimensions are. That's the height of the prism. And this, you'll notice they're all marked congruent. This is the side length of all. That's the side length of all the sides of the base. We're finding the lateral area, the perimeter of the base times the height. The perimeter of the base lateral area is 141.12, 141.1 meters squared. Any questions? Surface area is 2 times the area of the base plus the perimeter of the base times the height. What looks harder is actually easier. We don't have to find the area of the base. So 2 times 80.6 plus the perimeter of the base that we already found, 33.6 times the height of the prism, which is 4.2. So we're going to put all that in because we want to make sure we want to be as precise as possible. So 302.32. Anybody else do the same thing? 302.32 would be 302.3. Anybody get something different than 302.32? Anybody else do it? Okay. So that would be the surface area, and the volume, even easier now that they gave us, area of the base times the height. Area of the base, they told us, is 80.6. This is a given. 80.6 times the height of 4.2. $338.52, so we're going to round that to 338.5, and that is cubic meters. Any questions? All right, and the last one is an oblique rectangular prism. Right? This we have to know is the height. Remember that perpendicular? That is how tall this prism would be if it were standing on its end, or standing on the base. So we're only finding the volume, area of the base times the height. The base is a rectangle. This one times width times height. 2 times 4, the height of the prism is 16. think it's 128. 128 cubic centimeters. Any questions? Yeah. Which one? Okay. Does everybody see this page before, or this slide before I go back? Okay. That one? You can scan and submit your notes, and then go ahead and get started on your homework. Do not pack up. Yes, hurry up. Put your name on the calendar and time. We have a little over 10 minutes. Leave your phone.